Mario once again with MIA Microflight. In this video I'm going to show you how I make these leaf contact switches. If you were to buy these online, you'll probably spend about $5 and up, so they're not that cheap. So I decided to make my own because I had these strips of beryllium copper. This is the type of copper strip that if you restrain it and you push on it, it springs right back out or right back into position. As long as you don't overdo it, and you don't kink this material, it has that spring quality there. So it's perfect for doing stuff like this, and this is what I'm going to be using to make what you see here. So what you're looking at is two contact switches that are part of this bumper setup here that you see here. And I'm not quite done with it, but I thought I just capture this because this is about the contact switch that I'm making. And so this is the 3D printed part that I'm about to print. This is going to have the two strips. Of course, I'm going to have to make that little V there just so that it makes a better contact with the leaf at the back. These two pieces will be perforated so that I can insert a nylon bolt here and a nut. This has a width of about 0.125, 1/8 of an inch, and so these parts are designed around that dimension. This also has a thickness for anybody that's interested in getting this online. If you want to get this material, this is a 0.00. It's about I would say 0.01 in thickness. So go with that dimension because this is a little bit on the lighter side. I do have some thicker ones that I could use, but it's the same material, beryllium copper. The bumpers, the way that I've seen done, looking at the full-scale ones, is I believe they have two bumpers, and the reason for the two, not the two bumpers, the two leaf switches, is so that you have a much better contact if the ball were to hit anywhere along this bumper here. So typically they're positioned at the ends, from away from the center on the sides, from where the kicker arm is located. So the kicker arm is going to be located at the center of this bumper setup here, and that's what you're seeing here. Basically, I've already established my center line and center points and pivot points. So this is going to be my pivot point right here. This is where I'm going to pivot this arm. And I need to make another part here just to make everything nice and easy to operate, so nothing binds. So this is going to have another part here. The ones that I've seen have also another part here, sort of triangular arm, another extender arm here that makes that makes the connection to this arm right here. And when this pulls down, this basically kicks the ball that way. It activates the solenoid. The solenoid gets activated, and then the arm also gets activated by that motion there. And so this piece right here basically is right behind the rubber bumper. That rubber O-ring that typically these pieces, these assemblies have. Right now I have a band here, but typically that's just like an O-ring, a rubber O-ring. I am using silicone rubber because it's got a much more spring action than any other type of rubber, the O-ring or band that I've used. So just keep that in mind. Silicone is much better. So I'm about to complete this assembly here. I need to make these two pieces here are probably going to be joined by another bracket that's going to support the pivot point of this arm right here. I need to make this arm a little bit wider here, so we can see that probably going to be something like that. Let's make that 0.25. Oops. 0.25, not 25, 0.25. Okay, and then what I'll probably do here is slot this area here so that I can bring another piece of 3D printed part that's going to join this and this part right here, and so that'll keep things nice and nice and easier, a lot smoother to operate than if this part were to be joined directly to this couple, to this shaft right here. So I'm going to be finishing this, but this piece right here, these two pieces are going to be part of the bracket that's also screwed from underneath the table. Of course, these has to go through a hole on the table, so this is probably going to have a three perforations, one for each of these contact switches and one for the center kicker here. So that's what I'm going to be finishing, but I just wanted to capture this on video and explain how you can make these leaf switches here. Really simple. With you can get yourself some of these beryllium copper strips. Now this strip right here, I actually these are some loose parts that I had from this is Jesus, this is probably back from 1992. I've had these pieces. I never really used them until now that I'm doing this project here. And this is just a personal project for fun. I don't plan on selling these things, so that's why I'm sharing all these tips and designs here that you can if you watch this, you can pretty much just copy it and do it yourself. If you have the ability to do 3D printed parts, do them on a CAD software and assemble these parts yourself. But it's not really hard, because this is just a piece, like I said, beryllium copper. So I had these pieces from a project when I used to work for a company. I used to work for an industrial design company back in '92. It was one of my interim companies that I worked for before establishing MIA Microflight. And so in that capacity, one of my primary job was to manage an SLA machine, one of the first SLA machines in the United States back in '92 that used Ciba-Geigy resins. If anybody's familiar, with I believe that machine was a 3D Systems SLA machine. So it was a big machine. I was one of the very early machines. I used to manage that, and I used to operate that machine. And any time that I was idle, I would go down to the model shop and assist the guys with the model shops. They used to make a lot of models, mainly Motorola cell phone prototype models. They did a lot of work for IBM computers, so a lot of industrial design stuff. And so I worked directly with the model shop anytime that I was, like I said, idle. And one time I was assisting my boss in a manufacturing of a prototype prototype for a cell phone, and so it. One of my tasks was to find some copper strips, beryllium copper strips, so that we can make the contacts, for the charger. And so I went to an industrial place. I got a lot of samples. Back in those days, you could get samples for free. Now it's a little bit harder to get samples from companies unless you're a well-known company and you're making a huge product or something that's that the raw material supplier thinks it's worthwhile sending you or giving you samples. But back in those days, I used to get samples, a lot of samples. And so this is a copper plate that I got a good size sheet, and then I sliced that on the chopper. They had a metal chopper, and so I sliced these really thin, so that we can make contacts. Then we send these out to get them electroplated, for the final prototypes. Those cell phone. It was a cell phone battery charger or a battery for a computer charger. I don't recall the exact details of that, but I remember it was some kind of a charger. So I worked with my boss on that project. My job was to make all these little parts and just kind of assist on and off on some of those projects with the model shop. So I had when that project was over, they were discarding a lot of the stuff went to the garbage, and so I collected a lot of the stuff, kept a good portion. A good portion went to the recycling bins, but now it's coming in handy, so it's just how the world is. Sometimes what they say, it's somebody else's junk is another man's treasures, and for me, stuff like this is valuable. It's I may not use it right away, but I like to keep parts like this so that I can when when the creative juices start flowing, I can start making things. And look at this, now I got the perfect parts here, and so I'm saving myself $7. I was going to pay for one of these recently, looking since I couldn't find it. I go, wait a minute, I remember I had some of this stuff, and I go, I can make my own. And so this is what this video is about. Any comments, any questions, put them down below. And yeah. Stay tuned for more.